Hello and welcome back. Today we're going to look at materials and how they're going to allow us to reuse the same shader for multiple objects in the scene, but still have some agency over how those shaders are being used for each particular object. So if that sounds interesting, please stick around. Remember to hit that subscribe button and give me a big thumbs up for the YouTube algorithm, and let's get into it. So what we currently have is somewhere we need a VA and a shader, right? And these two are used to actually render something on the screen. Let's say we have a shader that specifically likes to draw circles, and it takes in a uniform for the color. Currently, with our deferred rendering pipeline, we actually have no way of using the same shader for two different circles, right? So if I had circle A that I want it to be red, and circle B that I want it to be green, I actually don't have a way to do this with my deferred rendering pipeline. Our rendering pipeline is just going to take in the VA and the shader, and at some point in the future, it's going to actually run through them and render it. So we don't yet have a mechanism for specifying a uniform sort of per instance, right? The uniform obviously must be different for A and B. So how can we specify different colors or different uniforms for the same shader? Well, that's where materials come in. So if we have a material that sits on top of the shader, the material can track color equals red for this particular shader. So a material would know about the shader it cares about, and it would be able to set all the uniforms, right? It basically keeps a state of all the uniforms for a given instance of a shader. So if we have this material, we might call it red circle material, right? And this material would define, this is the shader I'm using, and these are the uniforms I want for that shader. If we can get that working, then that allows us to have a second material that can set the color to something else like green. And now we might call this green circle matte. So now in our deferred rendering pipeline, instead of providing a VA and a shader, we'd provide a VA and the material. And the material knows which shader it cares about, but it has the additional context. And so when it comes time to actually render this VA with this material, the material's job is to populate all of the uniforms for its internal shader with the values that it has cached. And so once we've created these two materials, I can say render A with the red material and render B with the green material. And that way, if we make a fix to our circle shader, that will update the shader here, and our materials can stay as they are. So that's how we're going to pull this off. So let's get into code and start writing this out. So as always, let's start with creating our class. So in the graphics folder, I'll create a material class. And the graphics folder down here, I'll create the CPP. And we'll go back to the header. So first thing we need is that reference to the shader. So let's go ahead and forward declare that. And this will be a shared pointer, so we'll include memory. Great. Now shaders, they'll have uniforms, but they also could refer to textures. And because the texture needs to be bound, we also need to track that. So let's add the ability to have a texture here as well. It doesn't have to be used, but it needs to be there. So instead of shared pointer to a texture. And this could actually eventually become an array of shared pointers to textures because technically, depending on your graphics card, you can support like up to 32 bound textures at once. And a single shader could actually reference all 32 of them. But for now, we'll just stick with one texture. That's all we need. And now we have to think about how we're storing those uniform variables, right? If we switch over to shader for a second, in shader, we only store the names of the uniforms, right? And then the integer is just the location of where the uniform lives. And this is so that next time we set a uniform, it's a quicker lookup, and it doesn't have to go back to OpenGL and request that location again. And that's why we have this get uniform location thing. But the thing is, this doesn't track any of the types of the uniforms, right? It's just the names. And I need to know as the caller which type I want to set. So I want to set a uniform float 3 with this name, and here are the values. So we need something that sits on top of this and allows us to call these as needed. So what that means is that technically our material could hold any number of integers, any number of floats, so float 2s, float 3s, and float 4s, right? It all depends on the shader and what it supports. Maybe it wants 10 integers as uniform inputs. So we need to support an arbitrary number of each data type. So the way we're going to do that is back in material, I'm just going to use unordered maps of strings to the type. So we'll do this for all of the data types. So std unordered map, so string to int for m uniform ints. Then we'll need a float for m uniform floats. Let's include unordered map. And we'll include GLM as well, since that's how we'll track our vectors and matrices. Okay, now notice I'm not storing anything in particular for textures. Textures are technically just integers, and we can set them separately, but again, because I'm only ever dealing with a single texture right now, I'm not going to bother with it. So I'll start with our constructor, which must take in a shader, right? Our material has no context or doesn't mean anything without an associated shader. So we'll force you to pass in a shader. And then you can optionally pass in a texture. We'll default it to null pointer there. We also need a copy constructor. And a distractor as well. And now some getters. So for example, our render command will need to know what the shader and texture are so we can bind them. So let's get those. And then we can also set these in case we want to change them after we've instantiated them. I could make these inline, but I do want to assert if the shader you pass in is null pointer. So I'll just do these in the CPP. Now we're also going to need is a function to actually set all of these within the shader itself that the render command will have to run before we can actually render, just to make sure that the shader on the OpenGL side has the updated uniforms. So we'll add that here and we'll call it maybe update shader uniforms. And this is enough to start working on our CPP side. So let's include okay, and the material, all it's going to do is set the shaders, right? So shader, texture is texture, and then we'll have to assert again here if shader. Copy constructor just copies everything over, so shader. Perfect. And I don't actually need anything in my destructor. So let's just leave it empty here. Okay, and the set shader, so similarly, we'll just want to assert first that shader is not null pointer, and then shader equals shader. Maybe we'll only do this if it's not null pointer. Texture, we can just set it. We might want to like turn off the texture somehow, I guess. And now to update the shader uniforms, this is pretty straightforward. We just ensure that we have a valid shader, and if so, we'll just iterate over every unordered map and just call the set on the shader. That's pretty much it. We do need to know what shaders are. Great, and I'll do this for everything. So ints, floats, float2s, and that's it. This is the key to the whole point of why we have materials, right? Good. Now the only thing that's left is actually being able to set these, right? So we're going to do that with a templated class because that's the easiest way to sort of pick the right thing here. So let's do that. We'll do a getter and a setter too in case anybody wants to get the values. So the getter will return a t, get uniform value. Now I do need string here. Now if we remember from our vertex.h, we have type traits, right? And type traits allow us to do this sort of check. Here I do it in insert, but here I do it actually in line, and if we if const expr stuff so that only one piece of code is run. So we're going to do the same thing. So I'll take that type traits header and we'll put it up here. Maybe let's just go back and take this line just so we have the syntax correct. So this is what my check would look like. If const expr is same t with int, then I want to do something, right? And what I want to do is first check if the name exists before we try to grab it. If it does, return it. Otherwise, I want to be able to provide a default return. So something that either could mean no value exists or something that could just be a safe default. So let me just multi-line this real quick. So we just check if mUniformInts.find name does not equal mUniformInts.end, right? That means you found it, so we can just say return mUniformInts at name, right? And then else we can return something like 0 might be a safe default, right? Now this is going to get pretty verbose the entire way down, so what I'm going to do is just quickly macro this just right here. So I'll just do a define, let's call it get uniform value, and we'll pass in the map name and a default return. And this is just going to basically be this. Don't need an else actually, we can just return here. And I'll just indent everything there. So now what I'm saying is, okay, here's my define. It's called get uniform value with a map name and return default return. So we'll use the map name here instead of obviously the specific one. Name, because this is just going to replace code name, we can just, we'll use the same value name as here. And then this is also map name, and then the default return will be used down here. And actually, so that we don't have to find it twice, actually that's constant time lookup, it's not a big deal. But let's just make it a little cleaner. I could just make this a const auto reference it equals map name dot find name. That way I've already sort of retrieved it, and then I can just say if it, then I can just return it-second. Yeah, we got to escape the new line there, and yeah, I think that's better. So let me just run through that again. So const auto reference it equals mapname.find name. If it doesn't equal mapname.end, then you can dereference it safely, return it-second, which is the internal value. Otherwise, we'll just return default return, and we don't actually want to escape the last new line there. Cool. So this is what I'm going to do now, and I can do that here instead of all this, right? So this now becomes get uniform value, mUniformInts, and the default will be 0. I don't need a semicolon. So we can now put this in a single line and do it for all of them. And for matrices, we want our defaults to be 1 since we want them to be identity matrices. Okay, and I think what I'll do is else all of these so that I can have a final else. And here we can just, we'll just statically assert. Okay, good. Now we can do the same thing for the setter, except setter will be a little simpler. We don't have to use this define. And then we'll have to also pass in the values. So a t, let's do a const t reference val, just because it might be a GLM mat3 or mat4. Instead of this, we'll just say m uniform ints at name equals val. Right, that's simpler. For floats at name equals val. Probably like copy this and then I like this multi-line selection thing Visual Studio has. Okay, perfect. And then one last thing I want to do is I don't want this to like exist outside of here. So once it's done, we can just undef get to uniform value so that it's gone. Okay, great. So now we should be able to set whatever we want on this thing and be able to retrieve it. So let's just test that first to make sure we're okay so far. So let me include material here. We'll create a material red. So here we'll initialize our material. So material red equals make sure material, you'll pass in a shader. So we'll pass in shader, which will just be rect, and no texture. So we'll leave the rest as is. Let's say material red dash arrow set uniform value. So let's just do this. Test would be 0. Actually, let's do 10. Great. Material red set uniform value test 2, and we'll pass in a GLM vec2 of 5 and 7. And now let's just trace it out. So hippo trace test 2, test 3. This will be material red get uniform value. Now with get, you do have to specify the type because you're not passing it in. So I want to get an integer by the name test. Then I want to get a GLM vec2 by the name test2. This will be .x and .y. That's a float. I could pull this out, but whatever. This is just testing. And then we'll do a, let's say, float test3 and see what we get back, which should be 0.0. Okay, let's run that. All right, main.cpp79. T equals GLM vec2 had a hard time in material.h line 58, so vec2. Memory for float 2's at name equals val. Let's see what the problem is here. So this is binary open square bracket. No operator found which takes left in the operative type const. Yep, this can't be const. It's always a copy paste thing. Okay, this must return a value. Yeah, I don't want it to return a value. So void, let's try that now. Okay, let's see. We've got, yeah, test 5 and 7, and 0 is our default float. Perfect. So that's working as expected. So let's get rid of this. And now let's work on the render commands. Because now we need a new one that takes in a material. And we don't need to differentiate whether it's textured or not. The material can do that for us. And we just check against that texture. So let's just take this. Create a new one. First of all, forward declare material. So this is the one, right? Yep. So this will be render vertex array material, I guess. We'll take in a vertex array and a weak pointer to a material. Perfect. Create that implementation. We'll include material. Let's bring this up with the other renders up here. So now we can pull out the shader and the texture. Oops, this should be matte. And now we can again assert here that the shader is correct. Executing valid, render material. Let's just say invalid shader for material. Or even just shader is null pointer. And now only proceed if we have a shader. Otherwise, there's no point in doing anything. Notice I'm keeping the unbind outside of the if statement here. So now that we know we have a shader, we should run update shader uniforms on our material, which means that the shader will be updated with the new uniforms despite, what the last state of that shader was. Now I can bind the shader, and then if we have a valid texture, then and only then do we bind the texture. Okay, and down here, same thing. So if we have a texture, unbind it, and then unbind the shader. Great, that's it. The rest can stay as is because we're rendering everything normally. All right, so switching back to main.tpp, we have our texture, we have our material. We actually don't even need a shader and texture anymore, right? We have our shader and texture libraries, and we can create our material based off that. So our shader will just be, let's grab what it was. This. Yep. And we'll give it a texture as well. So hopefully with this we see no difference, even though it's called material red. No shader, no texture, good. Let's put the material up here. So here, instead of setting this on the shader, we now set it on the material. So on material red, set uniform value. Good. Instead of pushing a render vertex array textured, we push a render vertex array material and pass in material red. Good. And then here, instead of changing the shader, we're setting the shader on the material. So material red, let's here set shader to this, rect, textured rect, and the same with the texture. That should be everything. So now we have a material, we're rendering materials. Let's see if it works. And if it does, we shouldn't see any difference. And there we go. Now we're properly rendering with a material, and we should still be able to change our material just like we could before. Nice. Now the whole point of this was so that we could render two things with the same shader, but with different values for that shader, right? So let's go down and update our shader a little bit. I think our rect one takes a color, right? Yeah, our rect shader takes a color. So this is what we're going to use to really test these materials. So we'll have a material red and a material blue. Or actually our background's blue, right? Let's make it green. We'll initialize red with rect and no texture. Material blue will be rect and no texture. And then a material red, right at the beginning, we'll set the uniform value of call to, what is it, a GLM, like 3 or like 4? to vec4. So glm vec4. This is red, so 1, 0, 0, 1. And material, I think it's green instead of blue. We'll do the same thing, but set it to green. RGB. And alpha. Cool, so now we have two materials, and actually, what we should do is have a material library, right? And then actually just modify which material we're set. So let's go ahead and do that. We'll have a material library that references things from the shader and texture libraries. We'll set these in initialized libraries. And now we'll just have a material that we're using. M material, perfect. And so MBA will be rect, and M material will say equals M material library dot get. Oh, did I not name it? I didn't name them, I just copied it. And yeah, this is going to change, so okay. This will be called red, or rect red, since it should be representative of what the shader and the material are doing in tandem. So rect red, and it'll be matte. And we'll do it again, rect green. This time it'll set the color to green. There we go. Can't just copy and paste sometimes. Okay, good. So that's all set. We'll have our main material, which is set to red. It'll actually be rect red, right? So I named it. Yep. Okay. This will be a material. And these actually won't really make sense. I mean, so here we'll just, it'll be the one we currently have equipped, which is kind of weird too, because it'll change the ones, like what is actually in the asset library. But this is fine for now. It's just a couple debugging tools. Anyways, now that I run it, you can see we're not properly applying our red material, right? And maybe I should have some buttons to switch between materials as well. So with these two new buttons, we should be able to flip between the materials on the fly, rect red and rect green. There you go. And again, this works because we're resetting those uniforms every time we go to draw them. So we can very easily switch between them without having to have two instances of the same shader. But again, we're not exactly where we want it to be. We want two different things being rendered at the same time. So this will be material 1, and this will be material 2. And so this material 1 will be red, material 2 will be green. And now I should be able to render them. So instead of having to like duplicate our position and size again for the second thing, I'm just going to offset it. So here we're setting the model matrix on the material. Let's say material 1. And let me just take all of this. We'll just scope this. And this will be, let's just do the rectpos.x plus 2 .f, I guess. That's where the second one will be. And this will be material 2's model matrix. Okay, and now we'll render material 1, and we'll render material 2. And now these, I think we'll get rid of them now. Okay, let's try that. And now you can see the benefit, right? So let me just move the camera over a little bit. Two different things being rendered with the same shader, and the only way we can differentiate both where they are in terms of model matrix and the color they use for that one same shader is with our material system. So this is really cool, but we're not quite done because there's one piece that I don't like about this right now. We're setting the model matrix directly into the material. What does this mean? Why is this bad? Well, what if I wanted to render them both with the red material, right? I would need two instances of the exact same red material just because they have different model matrices, right? So the model matrix is really the last piece that is specific to that instance, right? It's the last piece that doesn't have to do with the rendering in terms of what the shader cares about. It's only there to offset it and draw it where we expect it to be. So I don't like the fact that if I wanted both materials to be red, you can see that they're both now on the right side, right? Because we're setting them both to the same material, which is getting its model stomped right here on the second time. So if they're the same thing, they both point to rect red in the material library, they're both going to set the model matrix to the last one that happens to be called. And again, we care about this because it's deferred rendering. We can't just set this, then draw, and then set the other one and then draw. So the last thing we need here is a way to decouple the model matrix from the material. I want to be able to say, draw this VA with this material at this position. That will get us to where we want to be. And the way we do that is just with an additional parameter in our render command with a model matrix, right? We just pass in the model matrix and the render command itself takes that model matrix and stores it internally. So when it comes time to render, it can use that model matrix. So the first thing we need to do then is go to the render commands and actually add a model matrix in here, which means we need GLM. And I'll do it for all the render commands. There's only 4 now, right? So this will now also take a const glm mat4 model matrix. Okay, and we'll do the same for all 4. 2, 3. Oh, it's only 3. Yeah. Array textured, and array material. Yep. Okay, and then we'll set all of them when we call them. This makes me feel like we should have a parent class because there's a lot of copy paste, but it's fine. It's only 3 times. Okay, and now on this side, just like we do for a projection of view matrices for the camera, we'll do the exact same thing for the model matrix. So I'm just going to take this, we'll say shader set uniform mat4 for model, and it will just be a model matrix. It's that simple. Now I do want a proper default for this. We don't have one yet. We have to pass it in. So yeah, here. If I don't pass it in, we'll just default to identity matrix. I'll copy this over as well. Because yeah, you might not want to pass it in for whatever reason, in which case we want something that won't actually modify where it's rendered. So now it has a sensible default. You can pass it in and override it. And then we'll just say shader set uniform mat4 right here. And that prevents us from having to have it tied to the material or anything else for that matter. Okay, those are the 3 places. So now main, we don't actually do this anymore. This is gone. We would just calculate the model and pass it into the render call. And actually, this shouldn't even be an update because we're calculating matrices that are only used here. So what I'm going to do is just have it here, where the render call will just be internally here, and we'll pass in MVA and material1, comma, model. And then we'll do the same thing here. Now material1 and material2 can both point to the red thing. That's totally fine. The point is that we're going to still render them where they're supposed to be rendered. Okay, let's run this now. And there we go. Now we have both rects, both being rendered with the same material, but in their own proper positions. And so if I was to be able to, I don't know, add support to modify the material live, both would get updated at the same time because they're using the same material. It doesn't mean they live in the same space in the world. So that's the key differentiation piece. So let's change that back to green, just because I like seeing them that they're different, rect red and rect green. And that's much better. So that's it for today. Thanks so much for watching, and I'll see you next time. Cheers.